to write formulas for basic ionic compounds. Okay, let's start off with lithium oxide. The first thing that you're going to need to do is to look at a periodic table to figure out the charge for lithium unless you know it. Well, everything in group 1A is +1 or 1 plus. So what you can do is you can assign lithium's charge. You can write it like this: lithium, and I don't like that color. Let's start over. Let's get a better color. Okay, so we get lithium, and it's going to be 1 plus. That's what the periodic table says. You look at the periodic table for oxygen. Here you can see oxygen is -2 or 2 minus. And so you can write oxygen -2 or 2 minus, however you want to write it. Now the charges have to balance out, and if they don't balance out, you can switch, take this 2 and put it down here and put the 1 there. Okay, and what that does is 2 +1 charges cancel out 1 -2 charge. 2 +1s cancel 1 -2. All ionic compounds have to be neutral. The positives have to cancel out the negatives. It's kind of like this here. If we have a lithium here, and it's +1, and we have another lithium here, and it's also +1, that gives you a net of 2 positive charges. If we only have one oxygen, and it's -2, well, 2 pluses cancel out 2 minuses. The positives have to cancel out the negatives. One way that you can do that is by switching, taking the subscript from the 1 and putting it, or from the charge up here and putting it down here, and putting this subscript down there. That sometimes will even it up. It doesn't always work. I'll show you an example later where it doesn't work. Okay? But the positives have to cancel out the negatives. So I call it the old switcheroo. So you write the symbol, put the charge, write the other symbol, put its charge, do the switching, and let's see, that's supposed to be a 2, and you get Li2O, and then you never write the 1. If it's just 1, leave it off, because if you just write it Li2O, nothing there means there's 1. Okay, let's try another one. Calcium chloride. So you write calcium. You look at the periodic table, and you see that calcium is in group 2A, so it has a charge of +2. So you write that down. So +2. You look up chlorine. Oops, wrong way. So you look up chlorine, it's -1. And so you write chlorine -1. You take this and you switch them. So you switch, and basically what that allows you to do, 1 +2 cancels out 2 -1s. Okay, 1 +2 cancels out 2 -1s. You can do some multiplication. You can say 1 times 2, a +2, that equals +2, and 2 times a -1, that equals -2. The positives have to cancel out the negatives. So your formula would be CaCl2. Okay, let's keep on going. Let's do aluminum oxide. So if you have a periodic table, you can follow along. Aluminum, that's going to be +3. Oxygen is -2. Do the charges cancel each other out? No. So what you do is then you switch the charge. You put the charges as subscripts. And so 2 +3s cancel out 3 -2s. Because 2 +3s give you a +6 in positive charge, whereas 3 -2 gives you a -6 in negative charges. So it's just Al2O3. And when you're writing the formulas, when you get all done, you shouldn't put the charges on there. Okay, magnesium phosphide. You look up magnesium on the periodic table. It's +2. Let's see here, so I can show you that. Okay, so magnesium is +2. Next we're going to do phosphide. There's phosphide right there. That's going to be -3. So we put a phosphide. It's -3. The charges are not equal, so you switch them. And so you go to 3 there, the 2 that goes there. So you get Mg3P2. And so you would write that Mg3P2. Alright, now, sometimes you get this circumstance right here. So let's say we had calcium oxide. And if you look up calcium on the periodic table, it's going to be calcium plus 2. And oxygen is negative 2. If the charges equal each other, you only need them in a 1-to-1 ratio to balance the charges out, because 1 plus 2 balances out 1 negative 2. So you would just write that as CaO, and then you would be done. To write names for ionic compounds, and these are just basic compounds without polyatomic ions or transition metals. So what you do to start out with, to write the name, the first thing is the positive ion, and remember the positive ion is always written first. It's written just like it's spelled on the periodic table. So you would write magnesium, exactly like it's spelled on the periodic table. The negative ion is oxide. It comes from oxygen. So you write it, the root name from the periodic table, ox, then you follow that up with an "ide" ending. So those rules will be the same for all of these on this page. Okay, so number 6, you write the name of sodium. That's just how it's spelled in the periodic table. The positive ion is always written exactly like it's spelled, followed by the negative, the name of the negative ion with an IDE ending. So you'd write sulfide. And then this one is the positive ion, just like it's written on the periodic table, lithium, and then the negative ion with an IDE ending, so it's nitride. And there's no specific way, like how many letters do you cut off. It's just a matter of experience, learning to write the root part of the name, followed by then IDE. Okay, number 8, the positive ion is written exactly like it's spelled, followed by the negative ion with an IDE ending, so this would be sulfide once again.